Hello, everyone. Let's look at 8.6, the notes about binomial expansion. And I started to highlight binomial is really an expression in a form of a plus b. Well, a plus b could be x plus y, it could be 2x plus 5, it could have any number or variable in place of a or b. Let's look at how this pattern expands without any other information about what A and B could be. Let's just let A be A and B to be B. So starting off, expanding is taking this binomial to the nth power. So whatever amount you want to go to, maybe to the sixth, to the seventh, using this item goes a lot faster than trying to multiply it all out. So starting off, if I took a binomial to the 0 power, as a reminder, anything to the 0 power is 1. The variables would be gone, the numbers inside would be gone. It all goes to the 1. And then if it's to the first power, then I would have the a and the plus b. I would have the original binomial. Now to the second power, that's what that does. Let's just do it off the side and remember how to do it the old-fashioned way. And the old-fashioned way is a plus b times a plus b. Well, if you FOIL or distributive property and multiply it out, you would go a times a, which equals a squared, a times b plus ab, plus b times a, which doesn't matter which order the multiplication goes in, so I'll put a first, and then b times b gives you b squared. These two things are like terms. It comes out to be a squared plus 2ab plus b squared. That's exactly what this row has. It goes a squared plus 2ab plus b squared. Now, doing it the old-fashioned way is fine when it's to the power of 2, but as soon as we start going beyond power of 2, it gets messier to do it the old-fashioned way. So we have this awesome expansion that shows us a pattern that occurs. Notice that the squared, it begins with an a squared. The cubed will be an a cubed. The fourth will be to the fourth, fifth to the fifth. That's the starting of it. And notice how it ends. It ends in an b squared, b cubed, b4, b5. So it ends exactly as it begins, but with the second term of the binomial. Now, how does the middle come about? We're going to get to that. So starting off, let's look at some simple patterns that occur. First off, there are n plus 1 terms, the first being a to the n and the last being b to the nth. That means if whatever power it is, say it's 3, it should have 4 terms. That's term 1, 2, 3, 4. So there's always one more term than what the power is, and that's a good checking point when you're doing expansion and making sure you have them all. The exponents of a, this is number 2, decrease by 1 from term to term, while the exponents of b increase by 1. And I'll show that down here, and you can see that actually here too, say the 5th. So I got a to the 5th, and then it goes to the 4th on the next one, to the 3rd, to the 2nd, to the 1st, and a to the 0 would be in the last term. But again, a to the 0, anything to the 0 is 1. That's why there is no a value there. And b value would be b to the 0 starting off, which is 1, and 1 times anything is the other thing. And then it would be b to the first, second, third, fourth, and fifth. And you can see how that works. And then the last one is the sum of the exponents of a and b in each term is n. Well, that means if you're expanding to the 5th term, look at term 2. Let me use this other pen. So term 2 n to the power of 5, a is 4 and b is 1. That total amount of the exponent is 5. Well, that's what my n is over here. Is this one the same? 3 plus 2, it's to the 5th. So again, you can check to see if you did it right. Now let's look at how that occurs. So you can see again what occurs. We have a to the 5th because it starts with 5. So we start with the first term, whatever it is. Maybe it's 2x. You need to put parentheses, 2x to the 5th. And then it goes to the next one, to the 4th, to the 3rd, to the 2nd, to the 1st. That would be a 1. It doesn't have to say 1 because if nothing's there, it means it's to the 1. And then to here, which really is a to the 0, and a to the 0 equals 1, so I don't need to have it. And then for b, it would be b to the 0 right here. But again, b to the 0 is 1. That's why it doesn't show. And then it goes to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th. So you can see the pattern on how that works. Now the next question is, how do they get the numbers in front, also known as the coefficients of each term? How do we get the coefficients? Well, we have this awesome thing called Pascal's triangle. Some of you may have seen this before and some of you may not, but let's look at the relationship. Now, with Pascal's, remember we at 0, we're going to be at 1. Well, Pascal's triangle makes the outside of this triangle all ones. It always starts and ends with 1. Very nice and easy. So at 0, it's going to have a 1. If the power is 1 by the definition in number 1 up here, excuse me, where is it? There's always n plus 1. So if I have it to the power of 1, I know that I would have 2 terms. Well, it's going to be 1, 1. Not until the 3rd row or in exponent 2 will that have changed. And how it comes about, it's so cool. Pascal's triangle found out that you take the 2 above it, you add, and you get that middle one for row 3. Now, or you can call this row 0, row 1, row 2 if you want. This one, row 3, or you may call it row 4 if you're counting this one as 1 up here. Different professors say it different ways, but let's look. We take, here's the outside, so 1 plus 2 would make 3. And then 2 plus 1 would make 3. Remember, we always have one more term than the exponent itself. So at row 5, I'm going to have 1 and 1, and that makes 4 different numbers in between. Then we would have 1 plus 4, 4 plus 6, 6 plus 4, and then 4 plus 1. And you can see how that comes about, and it just keeps building and building and building. We can continue on, and it's going to be the same pattern all the way through. It is pretty cool. So let's continue on and look at some examples. So example 1, expand this binomial and by using Pascal's triangle. So I want x plus y to the 5th. Well, let's remember from the front side, I have x plus y to the 5th. What are the coefficients? I'm going to find the coefficients. Well, Pascal's triangle says the coefficients go 1, 5, 10, 10, 5, 1. Has a nice pattern. You'll get used to memorizing some of the very first ones, and then if you need to go further, you build off of that. I like to memorize the row 5 myself. It's pretty nice because it has 5s and 10s, and that's a 5, and so it goes quick in my head. Now let's take what we know. We know how to do the expansion now. Now, remember that on the expansion, this would be considered A, and that one would be considered B. So, remember, we have coefficient, so there's 1. I have A, which happens to be X, and it's to the 5th, because it always starts with the 5th, and then Y would be to the 0. Well, I don't need to write Y to the 0. Plus 5x to the 4th, and then y is going to be just to the 1st, because that goes 0, 1, and then plus 10x to the 3rd, y squared, plus 10x to the 4th, y cubed, x to the 2nd, I apologize. That's easy to do. I sometimes just do my x's and then I go back and fill in my y's, so I don't do that. Plus 5, and then x goes down 1, y goes up 1, and then the last one is 1, y to the 5th. X is to the 0, I don't need to state it. So now I've just expanded the binomial by using Pascal's triangle. Nothing more to do. That's it. Let's continue on to the next example in the next video.